Hello everyone. In this problem, there is a family with two traits, and the genes for the two traits are linked. They are located on the same chromosome, and we don't regard the crossover in this problem. So that means they are always inherited together. And each gene is controlled by two alleles. The first trait is determined by H allele, and the second gene is determined by T allele. And in each case, a capital allele is dominant over a lowercase allele. And in the pedigree, we don't know the expression of the two traits in three individuals, A, B, and C. But we know the B is male. So that means C is female, and A is obviously a female. Among these three individuals, one person has the first trait expressed. And in the table, these three people have a different number of lowercase h allele from 0 to 2. And A and C has the same genotype for the second trait. So let's make a pedigree with this information. And individual 1 to 5 has the first trait expressed. And individual 4 and 6 have both the traits expressed. The first strategy we can think of is that these genes are located on the sex chromosome. In such case, we can reduce the number of cases because male has only one X chromosome. So let's say these genes are on the X chromosome, and that means the individual B cannot have two number of lowercase h allele because he's a man. So that means either A or C has two lowercase alleles, and if the first trait is the dominant trait, that means the person with the trait has the capital allele H. But there is a problem in this assumption because either A or C is homozygous for lowercase h allele. If C is homozygous lowercase h allele, her son cannot have capital H allele. Or if A is homozygous H allele, once again, her son, number 4, cannot have a capital H allele because a son's X chromosome comes from mother, not father. So that means if the genes are on the X chromosome, the first trait is not dominant. So let's assume that the first trait is recessive. That means the individual with the first trait has a lowercase h allele. And in the case of female, number 5, she is homozygous for lowercase h allele. And because number 6 has one lowercase h allele, his mother must have at least one lowercase h allele. And then individual number 3, because she does not have the first trait, and she has at least one capital H allele. And then because individual number 4 has one lowercase allele, so that means his mother A has at least one lowercase h allele. And that means the individual B should not have lowercase h allele because one of them has zero lowercase h allele. So that means the individual B has a capital H allele. That means his mother, A, has capital H allele. So that means individual C is homozygous for lowercase h allele. So that means individual A has one lowercase h allele, B has no h allele, and C has two number of lowercase h allele. And then if we think about the second trait, it is likely that second trait is also recessive because more people don't have the trait. There are more people who don't have the trait than people with the trait. So that means if the person has the second trait, he or she has lowercase t allele. So that means individual C has the chromosome lowercase h and lowercase t linked. Individual number one, because he doesn't have the second trait, he has at least one number of capital T, 1 to 5. And that means individual C receives the X chromosome with a lowercase h allele and capital T allele from her father, and lowercase h and lowercase t allele linked chromosome from her mother. And the individual number 3 doesn't have the second trait as well as the first. She also has one capital T allele. And then from individual number 4, because individual number 4 has both a first and second trait expressed, her mother should have the X chromosome with one lowercase h and lowercase t linked. And because the genotype of A and C for the second trait is the same, because C is heterozygous for the T allele, A is also heterozygous for the T alleles. That means B receives the capital H and capital T allele chromosome from his mother. that's about the information of this pedigree. And if we choose the right statement from the box, the first statement is right. The first trait is recessive. And the second statement is not right. Among A, B, and C, no person has the second trait expressed because all of them have capital T. So the people with the second trait is 0. And for the third statement, if the parents of number 6 have another child, if we make the Punnett square, the probability for this child to have both the first and second trait is this. If he's a boy and receives the X chromosome with lowercase h and lowercase t linked, he will have both the first and the second trait, like his brother number 6, but not other cases. Both the traits are not expressed. So the probability for the child to have both the first and second trait is 1/4 is right. So from the box, the first and third statement is correct. So the right choice is number 3. That's it for this video, and thanks for watching.